Good morning and welcome. I'm Navneet, Joneja, the product manager for Google Storage for Developers, and with me is Mike Schwartz, an engineer on the team. We're here to talk to you about how you can store your applications data in the Google Cloud. So we're going to begin today's session with a quick introduction to the product and talk to you about some new features we're announcing at I/O this morning. We'll then walk you through getting started with using Google Storage, some more advanced features, several of which are new this morning, and then put it all together with a comprehensive end-to-end scenario. Now, there's a lot more to the product that we can cover in a 1-hour session, but we'll try to hit all the highlights. So what is Google Storage? At its core, it's a service that allows you to store your data on Google's proven storage infrastructure. It's designed to be extremely reliable with multiple layers of redundancy built in. It's also designed to be very scalable and fast. We've brought our many years of innovation in online storage and networking to bear on this product, so you have a product that scales seamlessly and is extremely fast. As the name suggests, Google Storage has a developer and business focus, but there's nothing stopping you using it for personal use as well. Several of us do. The product has a REST API, which is basically the standard HTTP semantics, and is supported by many third-party tools and libraries, several of which are open source. Authentication and sharing is extremely flexible, allowing you to implement a wide variety of use cases. We'll talk about some of those later in the session today. And the service features strong data consistency. So last year at I/O, we introduced into an invitation-only preview a product that was very simple, developer-oriented, scaled well, extremely reliable, very fast, and put you in control of your data and gave you mechanisms to share it. So this year, we're taking those 3 themes and deepening our focus in each of those areas. We're focusing more on the developer by moving to a more team-based account model, which maps more naturally to how teams of people work on a product. And along with that, we're moving management of Google Storage over to the APIs console, the Google APIs console, where you manage all your other APIs, so you can manage all the interactions from one common place. We're also introducing several new features in the areas of scalability and performance, starting with raising the size of objects you can store in Google Storage to 5 terabytes, up from 1 terabyte last year. We're also introducing a new storage region in Europe, so you can choose to store your data either in the US or Europe and get the same high levels of reliability, scalability, and performance, and the exact same set of features regardless of where you choose to store your data. We're also announcing support for streaming uploads into Google Storage. The benefit of this is you no longer need to buffer data on your servers. If you're trying to get data from, say, an external telemetry source or from an end user into the cloud, you can just start sending it straight into the cloud by using the standard HTTP chunked transfer encoding mechanism. So it's very easy and makes that use case a lot easier. And finally, Google believes strongly in simplicity, and Google believes in speed. And we're bringing those two together by building a performance that performs really well without any additional complexity, just works. So a great example of that is one of the common models when serving data over the internet to a wide variety of users, some of whom may be across the globe, is you find a reliable place to store your data, and then you stick an edge cache or CDN around it. With Google Storage, you don't need to do that. It just works. So I talked a bit about how we're deepening our focus on sharing and controlling your data, and we have several new features in that area to announce today as well. Starting with support for OAuth 2.0, the standard, which allows you to do a bunch of very interesting sharing and authentication and authorization mechanisms. Moving to a more project-based ACL model, so in conjunction with the team-based account model for using storage, you can set ACLs in a project-based manner, so you can easily set up accounts and ACLs that work for your team. Of course, you can always override that, but we wanted to make it easy for you to get started. And finally, we got a lot of feedback from our community that sharing was great, but they didn't necessarily want to have all the people they had sign up and share their data have Google Storage accounts. So we're happy to announce today that as of today, you no longer need to have your partners and customers have Google accounts to share your data. They can just have a Google account and you can share data with them. And we're also very happy to announce that for those of you who have been waiting for an interview to use the, invitation to use the service, the wait is now over. We're generally available, and we also have a free trial tier with a limited quota of bandwidth, storage, and requests through the end of the year. So great, we have a bunch of new features, we're generally available, and you can get started for free. But what do you want to use Google Storage for? Well, we've designed the service to be extremely generic, so you can use it for almost anything. You're limited by your imagination. But having said that, there's probably about 5 main buckets into which we see our users falling. The first is storing data for applications. A great example of which is, for example, if you want to have, say, a photo editing application, and you want to store photographs somewhere, you can store the photographs in Google Storage. If you have a data sharing mechanism you want to implement, we talked about the number of features we implemented in that area to make that easier. Storing data for computation is also a great use for Google Storage. And a great example of that is the Google Prediction API. So for those of you who haven't yet encountered that, it's a product that allows you to use Google's proprietary machine learning tools to detect patterns and meaning in existing data sets, and then use that knowledge to predict the meaning of new data sets. It's a great product. If that sounds interesting, there's actually a session on that tomorrow as well. Static content hosting is also a very common use case in Google Storage. And I talked about the fact that performance just works. And because of our HTTP REST API, it's a very natural fit. And finally, if you have high-value data that you want to make sure is either backed up or archived to the cloud, so you can either pull it down reliably and quickly if something goes wrong, or you want to cloud burst, or you just want to have a secondary copy available that you load balance across or distribute, that's another great use for Google Storage. We believe there's no greater endorsement for a product than that Google is willing to bet its own businesses on it, and Google Storage has seen very wide adoption across Google. So with that, I'd like to bring on Mike Schwartz, who will walk you through using the product.
Thanks, Navneet. So I'm going to talk today about various aspects, most basically the basic API and then the more advanced aspects that we're introducing today, and then provide an end-to-end scenario. Before I do that, I want to just go back to this slide that Navneet just had up. You probably noticed my picture there. So there's a lot of products inside of Google that use Google Storage. The reason my picture's up there is several months ago, I decided to move all the data out of my house, out of my personal data out of my house, into Google Storage. And so now I just have browsers in my home. And that's, again, an endorsement for how much I believe in the product. OK, so first step I want to show you, it's pretty quick and easy to get started using Google Storage. And for this, if you go to that link, actually starting this afternoon, that link will be live. Once you get to that link, you'll get to you'll click through and you'll get to a page called the Google APIs page. And from here, you can sign up for a variety of different APIs. You can see there's quite a few. And what you want to do is get down to the storage link and click on Enable Storage. And once you do that, you'll be presented with some terms of service, which you can read and agree to. And then once you finish that, then you just need to sign up for billing. And I've already enabled this account and set it up for billing. And at this point, I can come in and start using Google Storage. And for this purpose, I want to show you first, we have a simple command line tool called gsutil. And gsutil has a number of Unix-like commands built into it. So the first one I want to use is to create a bucket called gsdemo 2011. And once I've done that, I can upload data into the cloud. So for example, I'm going to use the gsutil copy, and similarly to Unix, copy -r, where we recursively copy everything that starts with data. I'm using a wildcard there. I have a half dozen files like that. And once I finish copying all those clouds up into the cloud, all those files up into the cloud, I can look and see what's in the. I can look and see what's there. And I can also use the gsutil ls-l command. And this will give me a little more detail, some object sizes and timestamps and so forth. OK, so that gets some data up into the cloud. And then one other thing I want to demonstrate here is it's equally easy to get your data right back out of the cloud. And for that purpose, I'm just going to reverse the order of the recursive copy and copy down to a local directory. And it's as easy as that. And that's actually an important point to us. At Google, we believe your data belongs to you, and it should be really easy to get your data completely out at any time that you want. So there it is in a nutshell. Getting started, just sign up, agree to terms of service, set up billing, and you can start using the service. Now I want to talk about the API. So as we've already alluded to, cloud storage is organized into buckets and objects, and you can create as many buckets as you want, but in practice, most users just create one or maybe a handful of buckets, and then they load that bucket up with many, many objects. You can have millions of objects. They can be anywhere from a few bytes to terabytes, any format of data that you want. And then the basic API uses REST, which stands for Representational State Transfer, which is just the principle behind HTTP. Basically, everything's named with URIs and acted on with a simple handful of verbs, get, post, put, and so forth. And so here's an example of uploading a file to the cloud called data.csv, and it's going to upload it into the bucket GSDemo 2011. And there's an authorization header. I'll talk about that a bit later. And then that basic REST request can be modified using HTTP headers. So for example, you can set content type and encoding this way. You can control caching this way. By default, objects are not cacheable, but you can make them cacheable for a variety of performance enhancement reasons. So that's the basic API. And now what I want to point out is we have a couple of layers of reference implementation. So you could just write a piece of code that talks directly using HTTP, and that's pretty straightforward to do. There's a lot of language level libraries that make that pretty easy to do. But once you start using some of the more involved features, it can be a little bit complicated. For example, if you ever need to implement signing, like HMAC signing for authentication, or if you want to use Resumable Transfers, a feature I'll talk about in a bit, having a higher level abstraction is nice. And in addition to being nice, it's also, we use a reference implementation to let you see a complete representation of how to use the API. Here's some code. And for this, our library level is Bodo. Bodo is a popular open source library written in Python. And here what you can see is I'm going to get the same object as you can see is being requested using the REST API, but it's a higher level of abstraction. It's basically you import a class and instantiate an object with that URI, and then just print the content out as a string. In this case, it's a pretty small object, so printing it as a string works. And then one level up from there, I already mentioned gsutil being a useful command, but in addition to being a useful command, it also represents a reference implementation of how to use Bodo for Google Storage. And additionally, there's this -d option, which is really handy. It prints out all the HTTP requests and responses, not the actual payload, but just the headers of the requests. And that's really useful both for just basically understanding what the protocol is doing, and also if you're trying to troubleshoot some problem in an application you're implementing, a lot of times this will give you some details about what's going on. So let me give you a quick demonstration of this. If I look, first I have a copy of that same Bodo program that I showed you with that reference implementation slide, and now I'm just going to run this using the Python interpreter. And you can see it just retrieves, it's a little short comma-separated value file. And so that's running it using Python. You can go in and set breakpoints and examine the state of the program if you want in Python. And then the other thing we can do here is I can use that same URL. And now I'm just going to cat it using gsutil. And you can see I get the data out, but before the data came out, there's the request. You can see the get, accept encoding, and authorization header, the response, a number of fields, including, for example, the E tag, which is a cryptographic checksum that's used to help maintain integrity of your data, content type, and so forth. OK, so that's the reference implementations, Bodo and gsutil. Now moving on, I want to talk about security and sharing, starting with authentication. So there's 3 ways to authenticate requests. OAuth2, which is the newest one we're introducing today, and I'll get to that in a fair amount more depth later. Web browser login, which basically means once you've logged into any Google service, that set of credentials that you've logged in with can be used to access controlled content from Google Storage. So that's pretty convenient. Once you're logged into Gmail, for example, you can also get to your Google Storage. And finally, HMAC-based request signing. And this is an authentication mechanism that depends on a shared secret between you and Google Storage. So here's another example of a put request to upload an object to the cloud. And here I'm showing a complete authorization header using OAuth2 standard. This particular credential is not valid. It's just in the right format, but it's just to illustrate what an OAuth2 credential looks like. So that's authentication. Now for access control, the way access control works, every bucket and every object has an access control list that specifies who can access and do what to the bucket and object. And it's all controlled using this get and put syntax with a question mark ACL at the end. So here's an example for what you would see if you retrieve a particular object's ACL. And I've highlighted the parts that are particularly interesting. First, there's a grant to the owner of this object, gsdemo2011@gmail.com. And that's a full control grant, which means that owner can both read and write the object and also can read and write the access control list. And then below that is a grant, a group-based grant to this mailing list, gsdemo2011-guests@googlegroups.com. And this is actually a really powerful mechanism because what it means is you can set an access control list on many, many objects and buckets, say millions of objects and buckets, and then centrally administer that from the Google Groups console. So this is a nice way to do it, for example, if you have a bunch of objects that need to be shared by everybody in your company, and as employees join and leave the company, you can just go edit in one place and affect the access control for everything at once, rather than having to go individually edit ACLs on individual objects. Okay, so that's it in a nutshell. I've gone over the basic API, and with that, with gets and puts and the access control and authentication mechanisms I talked about so far, you can do a fair amount. And that's mostly was things that were available last year, although OAuth2 was not until this year. Now I want to talk about some more advanced features. The first one I want to talk about is, starting today, you can request that your data be stored in Europe. Before, you could only store data in the United States, and now optionally, if you specify a location parameter using at bucket creation time, you can specify where the objects are going to be located. And it's as simple as that. Once you've done that, the rest of the API is the same, and in particular, no one needs to know where the bucket's located to use it. So you make this decision where you're going to put the bucket, and then people can just use the rest of the API. And if you want, you can look up where a bucket's located using this question mark location syntax. Now, earlier in the presentation, Navneet mentioned that we support strong data consistency, and here's where I think it makes a really compelling case for why that matters so much. I mean, strong data consistency matters even if you're just using buckets and in the nearby location, but imagine the following scenario. You have customers all over the world, and a customer goes to upload some data using an HTTP form post into the cloud, and that form post causes a redirect to a server that you have that might be running in the United States. Now, Google Storage is implemented as a replicated set of servers running all over the world, and it's possible, and in fact likely in a scenario like this, that the web server is going to ask for the data from a different server than where the user uploaded to. Strong data consistency says that once the data has been written, any way you read it in the world, you're going to get the most recent value. That's as contrasted with eventual consistency, which only guarantees you would see a value that was current at some time in the past and will eventually come up to date if there are no more updates. And strong data consistency makes it much easier to implement applications because you don't have to worry about what version of the data they're looking at and so forth. So next, I want to talk about a feature called Resumable Transfers. And this is particularly useful if you're uploading and downloading really large objects. Suppose you're trying to upload, for example, a terabyte. And partway through the upload, your network connection gets interrupted. For example, you're walking between meeting rooms and your laptop goes through an area of limited Wi-Fi connectivity. If your upload is interrupted, with Resumable Transfer, once you get back into high connectivity zone, it can just resume again. And that's nice because you don't waste all the time that you already put into, suppose you already uploaded 500 megabytes. You don't waste the time and the network expense to re-upload that part of it. And so here's the way it works. When you start a resumable upload, the server will give you back an upload ID, and if it gets interrupted, you can use that upload ID. You can see it in the end of the URL there during the put request. And in response to that, this is the Google Data Resumable Protocol. Google server will tell you how many bytes it currently has, and then you can follow up by putting a content range put with the rest of the content. So that's how resumable upload works. Resumable download uses the standard HTTP range GET requests to do a similar thing. In this case, you don't need to ask the server. You can tell how many bytes you have locally on your disk, and you can just ask for the bytes that you don't yet have. So now what I want to do is give you a demonstration of both European buckets and of resumable transfers. And for this, I have a couple of windows open in two different cities, one in London and one Dallas. These are on machines that are off of Google's network. And the first thing I'm going to do is I'm going to create a bucket using this -L syntax saying in location Europe. If you don't specify a location, the default is the United States. And I'm just going to call it GSEU. So I've created a bucket, and immediately I can go over to Dallas now. And I can see the buckets there. Now I'm going to go back over to London. And I'm going to upload, I have a file locally that's 50 megabytes. And you can see as it's uploading, it's giving you a progress report. I'm going to interrupt it at about 35 megabytes in and start it back up. And you can see it started right back up where it left off. So that was a resumable upload. And now as soon as the upload is finished, I'm going to download it. And you can see the file is immediately available. And the download's going a bit slower because it's going across the Atlantic now. And I'm going to interrupt this download and start it back up again. And you can see it picked back up 4 megabytes where it left off. So that quick demonstration showed creating and using buckets that they're immediately visible. Once you've created in London, I can immediately start using it in Dallas. I could do resumable uploads and downloads. OK, the next new topic I wanted to talk about is OAuth2. We've mentioned it a few times now. What is OAuth2? Well, it's a widely adopted open standard for both authentication and authorization. OK, so it's being used. Google is moving all its APIs over to support OAuth2. And it's not just in Google. It's more widely used outside of Google as well. It's a widely adopted open standard. And the thing that's really powerful, there's a number of things that are nice features about it, but one of the things that's really powerful in my mind about OAuth2 is that you can authorize a web app to act on your behalf without giving your login credentials away. So think about it. This is important. If the way I gave access to Google storage was to give it my login and password, that would mean whatever account was going to go access, whatever application was going to go access Google storage could also, if it was unscrupulous, go access my Gmail, my buzzes, my docs, everything else that's all locked behind that authorization, those credentials. Instead, what OAuth2 lets you do is authorize a particular application only to access Google storage. It can't also access all these other services. So it's a much narrower scope of authorization, so that's in general a better security practice. And you can authorize different applications with different tokens and revoke individual ones if you want to. And finally, in order to implement OAuth2, you don't need to do any request signing. And if anybody's ever tried implementing request signing using OAuth1 or HMAC, you know it's kind of tricky to get all the details right. OK, so those are the new features I wanted to talk about. And now, to try to pull it all together and give you a better idea of what you could do with all these capabilities we're talking about, I want to present an end-to-end scenario. And here's the scenario. It's a photographer's preview service. And so think of it this way. Photographer goes and shoots photos at an event like a wedding or like this conference here, and then wants to make the photos available to people who attended the event. And there's a few different access control things that we want to do about that. First of all, we only want to let users see a watermarked version of the photo because the photographer is actually going to try to sell the photos. So we want to make a photo that the user can recognize but has a big mark across the middle so they don't have any desire to just keep that version of the photo. And we also want to make it so the only people that can see those preview photos are the people that attended the event. We don't really want it globally visible to the whole world. So that's the basic idea of the service, and it demonstrates a number of things. I'm going to show you using team-based development and management to build this application and deploy it. I'm going to show you domain-named buckets. So you can make buckets with a domain name in it, and this is useful if you want to brand the service or application you're deploying as being run as you as opposed to something that's in Google. I'm going to show you OAuth2 Authorization, and I'm going to show you group-based sharing using Google Groups infrastructure. So the first step in this is my IT guy comes along and he's going to set everything up so then the developers can work on it. And the first step is he's going to go create a project and register an application with Google's authorization infrastructure. And once he's done that, he's going to verify that he's the domain owner so that he can create a bucket. Google will prevent people other than you from creating a bucket with your domain name. Okay, so let me give you a demonstration of this. So this is the Google API console again, the place that we were looking at earlier in the talk. And the first thing I'm going to do is I'm going to set up API access. So when you click on that link, you can ask it to create credentials. And I'm just going to create a product name. I don't have a logo for it. And it's a web application. And I'm going to tell it to create a client ID. And at this point, well, it's kind of not very pretty formatting because the window's so large. But essentially, there's this client ID and a secret. And those two pieces of information you can stick in your application so that it can request credentials on behalf of a user. And the authorization service can know that that's this particular client. And that secret in and of itself actually doesn't gain access to anything. It's basically just to identify the client that you've just created. Okay, so I've set up an API. I've set up API access for my new application. And now I'm going to set up the team. And actually, I've already added the two people here. I've added a couple of developers and given them edit access. You can give them view or edit access. And what this does is it makes it so that once you've set up this team, anytime you go create a bucket, anybody who has edit access in the team will have edit access to the bucket. So it just makes setting up ACLs easier, among other things. Okay, so that's what the IT person's done. He's gone and create the project and registered the app. And now the next step I want to do is set up a domain named bucket. And for this, I have a little script. So the first thing I'm going to do is show you what happens if you were to try to create a bucket with a domain name in it that I don't have authorization for. So I don't own the domain example.com. Google Storage detects that when you tried to create the bucket, example.com, and says you need to go to this URL to prove that you own the bucket. And if you do, it would take you to a page that explains what domain ownership is and gives you several different options. I'm not going to go to that page now. Instead, I'm just going to show you the result of having already done that for my gsdemo2011.com domain. So here, what I did was, when I visited the Webmaster Tools domain ownership verification page, it generated a little text token, which you can see down at the bottom of the screen here, and asked me to write that into my domain name server. And the fact that I'm able to do that proves to Google that I own the domain. And there's other options too. You don't need to do it just using domain updates. Once I've done that, I can now go create a bucket, and Google Storage will allow me to do it. So I'm creating this bucket, photos.gsdemo2011.com. And at that point, the IT guy's job is complete. He's set up the project, created the team, set up the bucket, and now we can move on and bring in the development team. Here's my development team, and they're going to go implement the application, and they're going to test it using an access control list mechanism called Project Private, which basically means anybody in the team can read and write the bucket and see everything that's being created in there, but it's not yet visible to the rest of the world because they're still in the process developing and debugging this application. Once they finish doing that, they can deploy the app into App Engine and start using it. Okay, so the next step now is we've got this app up and running using this bucket that we've set up. And now we have a photographer who's going to come along and use the app. And the way that works is the photographer is going to go to App Engine and run the app. And the app, the first thing it's going to do is notice that the app doesn't yet have credentials for that photographer. It's going to request those via Google's authorization infrastructure. And that is going to, in turn, require that the user authorize the access. So you're not just giving it credentials to work with without first verifying that the user wants that to be done. Okay, so here I'm going to show this. So what I have here, first of all, notice that this is a I'm logged into Gmail here as this identity Pix, the photographer, Pix at gsdemo2011.com. And I'm going to go run this App Engine app. This is actually an application that I've uploaded to Google's App Engine. And what it does is it's going to try to acquire credentials. And the first thing it's going to notice is it doesn't have credentials that are authorized yet for me. So it's saying, do you want to authorize this application, Google I/O demo, to access Google Storage for developers? And if you click, you can find a little bit more information about what it's actually saying, view and manage data, and so forth. And you can also see what's going to happen once you do. So in particular, what happened was I went from App Engine. App Engine noticed it didn't have credentials and redirected to Google's authorization server. You can see it's logged in at Google accounts.google.com. And after authorizing, it's going to redirect back to my app down an app spot, but a different entry point, which is the entry point that will receive the credentials that are generated. So I'm going to allow this access. And at this point, the application's receiving the credentials. It's going to store them away securely in the App Engine credentials repository. And it's going to use those credentials to read and write buckets and store this watermarked photo. And now it's saying the photo is available at this link. And since I'm the person who ran this app, I can go ahead and click on this link and get to the photo. And now I want to make one other point, which is the comment I just made about since I'm the one who ran it, I can look at it. Let me bring up a different window here. Now, you remember that previous window was logged in as the photographer. The photographer ran the app, generated the watermarked photos. Now I want to see the view of the data that was generated by this app from someone other than the photographer. So here's my IT login, and here I have positioned in the address bar that same photo URL. And if I try to go there, I get access denied. And that's because when the app wrote the photo, it wrote it with an ACL that granted read access to anybody that was in the gsdemo-2011-guests@googlegroups.com group. And this identity is not logged in there. So let me show you what happens. I'm going to go sign up. So I'm over at the Google Groups console under GSDemo 2011 guests, and I'm going to go join this group. And you can also try this if you want. I promise I'm not going to harvest anyone's emails. This is just a little demonstration. I'm going to join this group. And once I've done that, I can go back and refresh, and now I can access the photo. So again, this is demonstrating that you can share with a group, and there's actually that group sharing mechanism. Actually, there's a couple different ways you can set it up. The way I have it set up right now, it just lets anybody who wants to go log in and sign up to be in the group. And that implements, for example, if you wanted a registry of everybody tried to access this photo. A different way of setting it up would be to have a central administrator who decides who gets to be in the group, and that's what you'd want to do, for example, if you're a company that was setting up the access control mechanism I mentioned before. You have millions of objects all set with the same grant to a particular group, and then you can just add and remove people from that group from here. So there's two very different kinds of access control models you can implement with this. Okay, so, and that's pretty much it. That's the part I just showed you with the guests that join and can view the photos and so forth. Okay, so moving on. Now I want to talk a little bit more about what actually happened with OAuth. And I'm not going to get into a lot of depth about this. If you want to learn more about OAuth2, I recommend there's a session about identity and OAuth2 that's going to be tomorrow, I think tomorrow afternoon at 1:45. You can check your schedule. But let me just give you a brief overview. So what happened was we set up the application, and the Google Authorization Service set up a set of credentials that we wrote into the application. And then when the photographer runs the application, it gets the app redirects to Google Store, to Google's Authentication service, which then generates a revocable token. It's called a refresh token. And that token can be used with an exchange protocol, which again, I encourage you to go to the OAuth2 talk if you want to learn more about it, to actually generate what's called an access token to access the protected storage, Google storage in this case. And one of the important points to note here is that access token is short-lived, and by default it lives for only an hour. So you're never actually sharing long-lived credential with a protected resource, which again is another nice security feature. And one other comment I'd make is if you get the latest version of GSUtil, which we just made available, It includes a subdirectory called CloudAuth that has the complete implementation of a web app that does OAuth2 based authorization to talk to Google Storage from Google App Engine. Okay, so just a recap of some of the business developer-oriented features that we've announced and talked about today. Support for large and streaming transfers, the ability to specify an additional location in Europe, projects and team-based development via Google's API console, ownership verification for domain name buckets, and then finally security, both OAuth2 and group sharing. So at this point, I invite people to go sign up. Again, this link is going to, the link that this takes you to, the actual sign-up page will be live this afternoon. And if anybody has any questions, I'd like to open up the floor now. And if people have questions, we'd appreciate it if you use one of the two mics here, by the way.
Could you put the URL back up?
I have a question for you. What does the pricing scheme look like for gets, puts, posts, all that jazz?
So you can go to, sorry, the question was about pricing for gets, posts, I guess storage and bandwidth as well. So the information is on our website, but just a quick highlight is storage costs 17 cents a gigabyte, regardless of where you store it. Transfer into Google's data centers is 10 cents a gigabyte. Transfer out depends on where you're transferring to. It's 15 cents per gigabyte in the US and Europe and 30 in Asia. And then requests are charged, the read type requests are charged at 1 cent per 10,000 requests, and the write type requests are charged at 1 cent per 1,000 requests.
I'm curious whether you see this as a service that's meant to be consumed on the back end by a web app or by users through a browser. Will the latency kind of support dealing with large files in real time for a web app?
So the question was web app versus end users making use of the service. You can use it for either. I mean, we're more tailored towards developers building, scalable applications. So in that sense, it's more of a back-end infrastructure. But certainly we have use cases of users accessing the data directly from the browser. We actually have a manager, a Google Storage Manager, which is a web-based UI for browsing as an end user. And I actually use it, for example, for moving data up and down into my home for the cloud. Yeah?
I have an Android app that I want to upload a file directly into Google Docs. Is there a way to do that? I mean, it seems like this might be a lower level API. Is there something in the Android SDK that allows me to send a file into a user's
into Docs?
Into users' GDocs?
So GDocs and Google Storage are separate services. They don't share data. There might be a way to do what you're talking about using the GData protocols, but it's not through Google Storage.
Thank you.
Yeah.
Why should I prefer to use the storage instead of the blob store on an App Engine application?
I'm sorry, I couldn't.
Why I should prefer the storage instead of blob store on App Engine?
Well, actually, we're working with App Engine. So the question was, why should you prefer to use Google Storage rather than talking to App Engine's blob store? We're working with the App Engine team to integrate the two so that they'll be the same. And it'll basically just come down to being your choice of whether you want to use App Engine or Google Storage API to get the data there. But once it's there, it should be accessible by both. That's not currently the state of things. We're working on that.
Will you work on providing the image API on top of storage, which is very good?
So the question was, will we work on supporting the images API on top of Google Storage? So I can't comment about future directions, but you can assume that if we're working on those features in App Engine, once the integration happens, we'll be able to use it over either.
So in your demo where you uploaded the file to a European data center and downloaded it from the US, that file was being served from that European data center directly, right? Is that, the first question is that exactly?
Well, the data lives in the European data center. The exact mechanics of how things are served are really something we can't comment about. But yeah, I mean, it does live in the European data center.
Slow download speeds from that US client.
Right, right.
Does that eventually get better? Is that replicated to a US endpoint and downloaded from there?
So you can turn on caching if you want. By default, it's not on, and the data is not replicated to the US. We keep it in Europe for a variety of reasons if you ask it to be placed in Europe.
So I'll build on Mike's statement and add that data is always replicated, but the way we do replication is within a region. And so we have two regions, the US region and the Europe region. So you will have replicas of your data in multiple data centers when you store it in Europe, but those data centers will all be in Europe. Now, talking about performance, there's probably a bunch of things going on between Dallas and Europe. I'm not sure what was happening today, maybe network congestion or something, but in general, performance should be pretty fast.
Question on large data sets. So if I'm starting with, say, hundreds of terabytes at the onset of my app, is Amazon today offers an opportunity where I can send them a drive, and they'll load that for me? Will Google offer something similar to that?
So again,
initial data load of very large size?
right. Again, we can't comment on future offerings, but we're definitely looking at lots of different things like that. And we're very interested in anybody who has ideas of things they'd like to be able to support, come talk to us. Always interested in hearing what your needs are.
I think you may have already answered it, but you can't comment on future directions. Asia coming online anytime soon?
Again, a future direction. Sorry.
Hello? Yeah. I have one question. I'm curious about the performance. For improved performance, have you considered to use some peer-to-peer technology to take advantage of some storage in the user space?
So the question is whether we're considered using peer-to-peer technology to make performance faster by taking advantage of users that might be near you that have already downloaded it. No, we're not doing that.
We don't do that, and again, as we spoke about, future directions, we don't comment. However, having said that, if you have thoughts and input on things that you would like us to do and use cases you'd like us to support, please do feel free to keep suggesting them. Either find us after the session or post them to the GS discussion mailing list, and we monitor that list pretty closely.
Hi, what kind of APIs do you guys have for dealing with a relational database and keeping records? So if I wanted to, say, SQL Server database synchronized in different places, do you have any specific APIs for dealing with that? Or?
Well, that's definitely not part of Google Storage. Google Storage API is really just a storage, not a database API. There's various other kinds of, products inside of Google that do database-like things, but that's not part of Google Storage.
Will you have the capability to cap, say, items per authentication? So say, for instance, a user can only download it once or twice based on their authentication. Will you have that as a feature?
Are you talking about limiting how much a user might end up costing because you put a limit on how many things they can do?
Yes.
So again, it's do you want to comment on that?
I mean, thanks for the question. I guess the short answer is, again, future directions. Don't comment too much about it. But, come and find me afterwards. Let's chat about what you want to do. And I'd love to just understand what you're trying to do, and we can see, if there's something.
We'll both be here for the next couple days, by the way. Thank you.
How you doing? Your demo showed resuming file transfers. So it looks like your system can accommodate ordered operations. And is there perhaps a head request where you can get file length so you can create your own chunking mechanism? It looks like it's all happening under the hood in GSUtil. Maybe you can talk about that.
Yeah, there is a head mechanism. And actually, when I scrolled back and showed you the operations that were going on using that GSUtil-D, I didn't scroll back far enough. The underlying Bodo library call actually ended up doing a head before it did the cat, so yes, you can.
So that's what it's actually doing to do the resume, so it figures out its place in the file, so it knows it's getting stuff.
Actually, for resumable upload, it's not using head. It's using a request to the server to ask what the server has. It's using that Google resumable protocol. So it's basically when you start the transfer, the server gives you back an upload ID, which is just a GUID, basically, a globally unique ID. You make when you put, again, you specify that GUID, and the server gives you a response back saying what it currently has. So it's not using head for that.
Thanks.
And that's a more general protocol than just Google Storage, by the way. That's used throughout Google, for example, when you upload attachments with Gmail, it uses that same protocol.
Hi. I had a couple questions. Does Google Storage support transport encryption and on-site encryption? And my other question was related to a previous question about, do you store metadata along with the files that you upload?
So the first question was, do we support transport encryption? And yes, we do. And in fact, we encourage it. Particularly with OAuth2, you want to leave using HTTPS. You want to encrypt the payload, including the credential information. I think the second question was asking whether we store data encrypted. Was that? So we don't right now. We can't comment about future offerings, but that's not the case right now. And the third one, I think, was about storing metadata. Was that right?
Along with the individual files.
Yeah. So you can store a limited amounts of metadata. You can actually set headers on objects when you put the object. And you can only do that when you create an object. The objects are immutable, so you can't take an object and then overwrite parts of it. You just write an object with the headers.
So can I build on your second answer as well, just to your question about storing data encrypted? I do want to explicitly call out that we do take strong security precautions with your data. We've probably seen the video of us destroying our hard drives, right? There's one on YouTube. But in general, the data is stored encoded, so even if you got hold of a hard drive, you wouldn't be able to do anything with it. But it's not encrypted. Like, it's not strongly encrypted.
Hi, I have a question about the business model. Does it support MSPs, or if I'm a third-party data management provider, is there support for that kind of business model in terms of whether it be pricing or how we control credentials? I mean, do we have to set up a different account for every customer that we have or every client of ours?
Could you just help me understand the scenario again one more time?
So, for example, if I'm a data management vendor and I want to provide data services for my client bases, I have 100 customers. Is there a business model that supports that, or do I have to set up? Is it going to be like a brute force, set up different accounts for each customer, or do they have to do them for themselves, or can I do it for them?
So that's a great question. And in fact, let's talk after the session, and I'd like to understand more about what you're trying to do, and we'll see if there's something we can do.
So you talked about using your home data and syncing it to Google Storage. Are you using like rsync or anything to keep that data synchronized, or is that a possibility yet?
It's not using rsync. There are third-party tools available that do a form of synchronization. They look at timestamps and MD5s and E tags. I think the one I use is S3 sync. Yeah, but it's not using rsync. It's not that protocol. Yeah, yeah. And actually, I think there are also some other third-party tools that are out there that work with Google Storage that give you a nicer kind of GUI interface to doing synchronization. Any other questions? Okay, well, if not, we're going to stick around for a while if anyone wants to come talk to us individually, or feel free to come grab us out in the halls. And thanks again for coming.